I kind of pretend in my own lame way that section 1.6, we're like Batman. We got this utility belt of all of these different techniques for how to calculate limits. So the next technique that we have is multiplying by a conjugate. And I need to tell you what a conjugate is first. Okay. So if you have something like A plus B, then the conjugate, you just change the sign in the middle. So that becomes A minus B. And if you have something like A minus B, then this conjugate is A plus B. Okay. And how do we know when we want to use this technique? If A or B involves a square root, this is a clue to multiply by the conjugate. Okay. So let me show you in this particular example. So for this particular example here, we have, let me just copy this. Let me put it here. Okay. And then what I'm going to do is I'm going to multiply top and bottom by the conjugate. So the conjugate of the numerator is going to be square root of x plus 2 plus 1. And whatever I do to the top, I want to do to the bottom because I'm only allowed to multiply by 1. So multiplying the top and bottom by the same thing is going to not affect the expression. Does that make sense? So, so you might be wondering, why are we multiplying the top and bottom by the conjugate in the first place? And the reason why has to do with the difference of two squares. So we had talked about a difference of two squares last time, I think. But just as a quick reminder, if you have A plus B times A minus B, this is equal to A squared minus B squared. So the difference of two squares factors in this nice way. The factors are actually conjugates of each other. So that's really great for you when A involves a square root, right? Because when you take the square of a square root, that removes the square root. So that's why I say having a square root is a clue that we want to multiply top and bottom by the conjugate. Okay. So we're going to do that. So just to be perfectly clear, our A in this case is going to be the square root of x plus 2, and our B in this case is going to be 1. So when I multiply this out, I get the limit as x approaches 3. I'm going to get a fraction again. The numerator, A squared is just going to be x plus 2 squared. I'm sorry, x plus 2. The square root was there, so the square of a square root is just that thing, minus 1, because 1 squared is 1. And the denominator, do not distribute the denominator. Just write the whole expression. So my comment is, do not distribute the denominator. Does anybody know why we don't want to distribute the denominator? Anyone want to say, or can you predict? Like, I think, if you're a good student, you always want to be like predicting or trying to guess why. Anyone have any feeling why we don't want to distribute the denominator? No feeling. Well, let's just continue this problem. And maybe you'll say why in a second. Okay. So I have this. And I want to simplify the numerator. So when I simplify the numerator, what do I get? Well, x plus 2 minus 1, that's x plus 1. So is it clear why we didn't want to distribute yet? Not clear. Or you don't want to say, well, you'd have to re-simplify. I think you know what you mean you'd have to refactor, Cynthia. So just so you know, simplifying generally means removing parentheses. So when we distributed, that would be simplifying. So yeah, you'd have to like refactor, exactly. Because the whole point is to cancel out this zero factor. That's the whole point, right? So like when you distribute, to cancel it out, you'd have to factor all over again. So yeah, I guess my point is we are trying to cancel the zero factor x minus plus 1. That says zero factor. My handwriting is bad today. Good. So we can see that they cancel here like this. So then what do I get? I end up with the limit as x goes to 3. Really, I would have just plugged it in on the previous step, but since I have this room here, let me just write it. And then what do I get there? 1 in the numerator. You get square root of 5 plus 1 in the denominator. And that's going to be our final answer. Okay. Do you think it looks better just with the yellow highlight, or does it look better with like a little box around it? You probably have no feeling. Okay. I want to pause for questions. I wrote a lot of comments in red here. I hope you can see I'm trying to review some pre-calc as we go along the way, because I unassigned all the pre-calc stuff from your class. All right.
Wait, sir, can I still see that? I'm trying to look at it still.
This guy?
Yeah. I'm like still a little confused as to why we don't distribute.
Right here? This distribute the bottom?
Yeah, like
do you see how in the next step I ended up canceling the x plus 1?
yeah.
So if I distributed it, there wouldn't be an x plus 1 to cancel. It would just be this 3 expression thing. Does that make sense? Like if you distribute, you're going to get, if you had distributed, you would have gotten x times square root of x plus 2 plus x plus square root of x plus 2 plus 1. So this all over x plus 1, this is not helpful. I can't cancel this x plus 1 like I wanted to. The reason why, oh, that's right. I totally forgot something. Hold on, I need a chill pill here.
Wait, I think I have like a better way to phrase where I'm confused.
Okay, wait. I have to tell you something else here first. I have a typo on this problem. My typo is that this guy is actually supposed to be a -1. Because when I plug in, I can just plug in 3. I could just use the direct substitution property here. The bottom is not equal to 0. I forgot to tell you about this typo here. So I have to delete that. But I want you to continue. You're going to say something.
Yeah, that's why I was confused.
Yeah, okay. Totally understandable.
Actually, I was also so for the numerator of the problem in the middle, like where it's x plus two, no, like same area,
Oh, okay.
x plus 2 minus 1,
Mhm.
but on the bottom the minus 1 is like not there. Where how did we like get rid of the minus 1? See, it's like x plus 2 minus 1, and then at the bottom is just x plus 1 now.
So
Yeah,
what's
so
2 minus 1?
1. Oh, so that's all you have to do.
Yeah. It's x plus 2 minus 1 is just x plus 1.
Makes a lot of sense, actually. Yeah.
Yeah. Nothing magical happened there. But this is an egregious error. And the stupid thing is I taught this lesson yesterday. I just somehow completely spaced out and forgot to fix the typo for you guys. So I only recognize now. So I gotta fix this. But yeah, that's all. We're just simplifying that. X plus 2 minus 1 is just x plus 1. So obviously I'm going to get a different answer when I substitute in -1 versus a 3 there. So we're going to get a final answer of 1 over 1 plus 1 is 1 over 2. Sorry about that. And this was just, if we had distributed, you would have gotten something ugly like this that doesn't really help you solve the problem. So Kenneth said, why would it not be okay for the x to approach 3? So there's nothing wrong with the x approaching 3, Kenneth, but I could have just plugged a 3 in from the beginning, right? I could just use the direct substitution property because you don't have any 0 in the denominator. That's all. Yeah. So like you would never even try this because the first thing you should try is the direct substitution property. Cool. So
I have another question.
go for it.
So another thing I'm a little confused on is what exactly is a oh wait, never mind.
Okay. Conjugate is you just change the sign in between the binomial expression.
Yeah, I couldn't read what that said, but then I took a closer look and I was able to read it. Yeah, never mind.
Yeah,
I said never mind.
I'm sorry. I'll try to write better. My handwriting is high variance. Some days it's okay, but a lot of days it's crappy, especially if I try to write fast. Well, I think this will be clear if you guys try one. So why don't you guys go to this classwork and try number 4. That would be the second. The first thing I would do is I try to plug in the 0 for h.
Oh, okay.
Just because remember I messed up the last one where I had the wrong number. I was going to 3, but it went to -1. So when I plug in a 0, I'm going to get the square root of 9. The square root of 9 is 3. 3 minus 3 is 0. So you get a 0 up top. You plug in a 0 on the bottom, you get 0 over 0. So we can't use the direct substitution property. Okay. Then the next thing I would do is I was trying to explain it carefully with the A and the B, but I guess I don't know if it's necessary to really explicitly write that out. I think the more important thing is to know what to multiply top and bottom by. So do you know what I want to multiply top and bottom by?
Is it 9 plus h?
Square root of 9 plus h. And then there's a 3 here. And do you know what the sign should be in the middle?
Minus.
No, because when you're conjugate, you see you have one term minus another term.
Oh yeah. So is it plus?
Yeah. And whatever you did to the top, you have to do to the bottom because we're only allowed to multiply top and bottom by the conjugate. So this guy looks like this. Does that make sense?
So when we conjugate, whatever we do to the top, we do to the bottom.
Right, because you're only allowed to multiply by one. You're not allowed to multiply the top by one number and the bottom by a different number because that's going to give you, you're changing the expression, right? But when you multiply by one, you're not changing anything. So we don't want to change, we want to change the way it looks, but we don't want to change what the expression actually is. So next, after we do this, we have to distribute. And what I was trying to say is that when we distribute, you can really just think of it as a difference of two squares. So when I multiply the square root of 9 plus h times the square root of 9 plus h, I'm just going to get a 9 plus h. When I do the inside parts, this and this are going to be exact opposites, so they cancel each other out. So I could show you that. We could do 3 times not square root of 9 plus h. That's the outside, right? First was this guy. The outside was this guy. The inside is this part right here. So that's going to be minus 3 times the square root of 9 plus h. And then the last would be negative 3 plus times positive 3, which is equal to negative 9. So when I go to write the denominator is just going to be h times the square root of 9 plus h plus 3, like that. We're not going to distribute, right? And then the cool thing that we see is that this middle part cancels each other out. It's the same, they're just opposite signs. So now we can simplify this even further. This becomes the limit as h goes to 0. The top is going to be 9 plus h minus 9. The bottom is going to be h times the square root of 9 plus h plus 3. And then you see how we have this plus 9 and this negative 9. Those guys cancel each other out. So now I just have an h left over on top and an h left over on the bottom. So it becomes the limit as h goes to 0, h over h times the square root of 9 plus h plus 3. Well, this is what I really want. I really wanted to have an h on top and an h on bottom because I want to cancel the 0 factor. So when I have that, these guys cancel each other out. And then we just end up with 1 over the square root of 9 is 3 plus 3. 3 plus 3 is 6. So you get 1 over 6. And that's the correct answer. Is there any questions about this? So
I'm a little confused after like the second step. Like after we got 9 plus h plus 3 over 9 plus h plus 3, I'm like confused. Like, how do we get the second part after that?
wait, you're confused here?
Yeah, right there.
How do we get this?
Yes. No, not like the cancel out. Like I get it why it cancels out, but I'm like, I don't get like how we got to that point. How did we get that equation?
So do you know how to simplify a plus b times x plus y? There's this thing you FOIL, right? So you got
Yeah.
to distribute. So it's first, outside, inside, last.
Oh, okay, I get it now. I get it now.
Okay.
But like, so if you do that for like both numerators and denominators.
No, because the denominator doesn't have a plus b, it just has a single number. So
So you just add it in there.
I'm telling you not to distribute because you want to cancel the h at the end. If you distribute, then you can't cancel the h.
Okay.
Mhm. Okay, we got to move on. It's right here. All right. So now we know two techniques. One technique is factoring and canceling. The other technique is multiplying top and bottom by the conjugate. All right.